Hello everyone, welcome to my channel. So today we'll discuss the third problem from Google Kickstart 2022 round H. Let us try to understand the problem statement. Here we are given with the n electrical junctions. Okay, so imagine we have three junctions, one, two, three. Okay, so and these three junctions have a capacity of AI. Okay, so here, for example, the capacity of uh, one junction one is three, capacity of junction two is one, capacity of junction three is two. Okay, so just to show that this has more capacity, I'm just changing the size of the circle, and same thing I will use in the next slides to explain. Okay, and also these three junctions are connected using n minus 1 edges. So right now we have three junctions, so 3 minus 1 is equal to 2. So it can be connection can be done anywhere. So for time being, I'll connect 1 and 2 and 1 and 3. Okay, so this is how they are connected. Imagine that there is a power outage and Ben can provide electricity to only one junction. He cannot go to all three junctions. He can go to any one junction and provide the electricity. And if he provides electricity to this junction, it can provide electricity to other junction which is connected to it only if it has more higher power. Okay, right now its capacity is 3, so it can give the power from here to here and also from here to here. But if Ben gives power to this junction, it cannot transfer the power from here to here. Okay, so our job is to maximize when find the maximum number of junction that can receive electricity. Okay, so let us build a test case for this in next slide. For the diagram which we discussed, this is the input. Okay, so here the number first they'll give number of test cases, and for each test case they'll give you starting an integer representing the number of junctions, and then they'll provide you the capacity at each junction. At junction 1 capacity is 3, at junction 2 capacity is 1, and at junction 3 capacity is 2. Okay, followed by they'll uh, n minus 1 lines, which is 3 minus 1 2 lines. They'll provide you how they are connected. Okay, so 1 to 2 or 2 to 1, they can give you the other way also, and 3 to 1 or 1 to 3. Okay, so for this when the maximum junction which can receive electricity is 3, because Ben can directly give electricity here, so it will travel from here to here and here to here. So answer is 3. Imagine that this junction 3 also has a capacity of 3. Okay, then in that case the power cannot go from here to here or here to here. Okay, in that case power can go, it can give, if it gives power here, then from here to here only it can go. So that case the case will become, the output will become 2. Okay, if this is larger than this, okay, okay, so say for example the power here is 5, then Ben can give power here, so from here to here, from here to here, then again the answer will be 3. I hope this is clear. Let us try to I mean, make a bigger example so that it's more clear. So let us consider our own example. So here I will take 10 junctions with 9 connections, and these are the capacities. Okay, so first we have this one junction here with capacity of 2, and second we have junction with the capacity of 4, then third junction with the capacity of 3, then fourth junction with the capacity of 5, and fifth junction with capacity of 7. This is the highest capacity. Okay, 7. And then we have sixth junction with the capacity of 4, then seventh junction with the capacity of 3, and eighth junction with the capacity of 2, and 9 and 10 with the capacity of 10. Sorry, 6, the capacity of 6. Okay, so now how they are connected with each other? So 1 is connected to 3, okay, and 4 is connected to 9, and 2 is connected to 3, and 1 is connected to 9, 5 is connected to 7, 6 is connected to 8. Okay, 4 is connected to 10, and 4 is connected also to 5, and 8 is connected to 7. So these are the connections. So we have n minus 1 connection, which is 9 connections we have. Okay, and I have actually based on their capacity, I have uh, the size is actually like smaller or bigger based on the capacity. Okay, for example, 2 is actually greater than 3 because the capacity of 2 is 4, capacity of 3 is 3 itself. So here what I do is just I just draw an arrow. Okay, so the power from here, if you supply power to 2 junction, it will go here now, and if you go power supply to this 3 junction, it won't go to 2, but it will go from 3 to 1. Okay, from 1 power cannot go anywhere. Okay, but from 9 power can come to 1, and same way from 9 power can go to 4, and from 4 it cannot go to 5, but 5 can come to from 5 uh, power can come to junction 4, and also from 10 the power can come to junction 4 because this has more capacities, and from 5 it can also go to 7, and from 7 it can go to 8, and from 6 it can go to 8, 8. Okay. I hope this is clear now. So based on this, if you just observe this carefully, right, here if you supply a power, it will only 1 2 3. Okay, so only 3 junctions will get power. But if you supply power here, uh, I think it's always good to start from the node which is actually going outward, right? So it's not good to start from here. So it's good to start from here and start like in the middle. Okay, so here also, but from here I think it's only 1 because there is no power going anywhere. From here it will go only 1 2 and 3, and there is, that's all. But if you give power to 5 junction 5, so it will go 1 2 3, and from here 4. Okay, that is the only maximum you have, because from if you give an power to junction 10 also with the capacity of 6, it will go only to 4, and only answer will be 2. That's why here the answer is 1 2 3 4 3 4. Yeah, so answer will be 4. Okay, let us now try to understand the logic. Okay, to understand the logic, let us consider the example from whatever they are given. Okay, the first set. So here first what we'll do, we'll create a list with direct connections only for those junctions which has the capacity lower than the existing junction. Okay, that is nothing but okay, for this particular example we have, this is the connections. Okay, and from 1 actually like we cannot give power from 1 to 3, so that's why, and there's no other junctions next to it, that's why it's a blank set. And from 2 also we cannot give power to 3, so it again is a blank set. From 3 however we can give power to 1 and 2, so we'll save that value, and this we are saying only the direct connections. Okay, and from 4 we can give power to 3 and 5, and from 5 we cannot give power to anyone, again blank set. Okay, so the same way you can actually after this list, creating list 1, again create one more list. Now from using the above list, try to find out direct and indirect connects total. Okay, keep on adding them. Okay, right now here for this, right, we have only one, there is no power going anywhere now, so only including that junction we have only one. And for 2 also we have only one junction, power is not going anywhere. For 3 we have 1 2 3, right, 3 junctions we have. For 4 we are just adding that junction 3, so we 3 plus the existing one. From here to here we have this and this, including these two, and the junction 3 we have 5. So direct connections we have 1 2 only, 1 2 plus including that also we have 1 plus here 2. I hope I'm making some points here. Okay, so that is how we have 5 here, and then finally we have 1. Okay, 5, from 5 power cannot go back to 1, now 4, that's why we have only 1. And the sticks represent the capacity here. Okay, so based on the capacity it cannot go from 5, it cannot go to 4 because it has 3 capacity here, yeah, capacity is 4. Okay, so finally you once you made this list, then find the maximum of that list. Okay, list 2, which is nothing but 5, so answer is 5 here. For second example, okay, we have 6 junctions. So and this is their junction capacities and their connections. Okay, the power cannot go from 6 to 1 because 6 has capacity, sorry, from 1 to 6 it cannot go, from 6 to 1 it can go. Okay, but 1 to 6 it cannot go. So and from here also it can go from here to here, here to here, but it cannot go from here to here because it's the same capacity. It should be lower than that. Okay, so here also from here you cannot go to here because it has lower capacity. So total we have answer here is 3, but let us see how to, let us create the first set for this. Okay, for this we have empty set because actually the power is coming inside from both sides, so that's the empty set. There is no power going out, and from 2 the power is also not going out, that's why again it's empty set. Then from 3 the power is going to 1 and 2, and from 4 power is going to 5 only, and from 5 nowhere, and from 6 its power is going to 1. So this is the direct connections with the lower capacities, and then we create a indirect connects, okay, using that. So 1 1, so from here if we just try to calculate everything, so here there is no going anywhere, no, so including only that junction we have 1, here also we have 1, and here we have 1 2 3, okay, these 3 connections. Then we have 2, for 4 we have 2 because from here it can go to here only 1 2, okay, and from 5 again nothing, only that junction, and 6 from here to here, that's also 2. Okay, so maximum of this is nothing but 3. So we have answer as 3. I hope this is clear. So let me know if you have any doubts. So next we'll check the Python code. So for every test case, read number of junctions and their capacities. Let us save these capacities in list A, okay, and then create an object that's in a dictionary of for connections. And since actually the capacity as list and the index starts from 0, right? We are here also we'll start actually like I, which is like range n, which is 0 to n minus 1, and let us keep it blank set for n junctions initially. And here we'll try to save using this next n minus 1 lines, right? We'll try to save the lower capacity, okay. So for every node we'll check whether the if it's equal then continue the loop, or if it is whichever is a greater, right? For example, node 2 is greater than node 1, then for node 2 add node 1, okay. So that connections you need to create that, okay. So and same thing, if it is node 1 is actually greater than node 2, then just node 1 capacity is greater than node 2, okay. Here we are doing right else part, so then add that particular node 1 to node 2, so node 2 to node 1, okay. I hope this is clear, and I'm using minus 1 because I'm using list, right? That's why. And after this actually you need to do like let us, this is a, here we have a list, first list which we discussed in the previous slide, okay. Now we have to create second list, let it be 0 initially, okay, 0 into number of junctions, and for every this particular junction, right, let us get the number of indirect connections using the functions, and here we are using recursion, okay. And let us to make it optimal, so let us if it is not equal to 0, if you already updated it, let's pretend as it is whatever we have, because one junction can connect to one junction can have more than two connections, right? That's why if it appears again, then return same thing. Otherwise first make it 1 to consider including that particular junctions, and then for other junctions which we use in the dictionary, right, connection dictionary, which we have it over here, connection dictionary, same thing we are passing here also, okay. Just get that particular connections in that junction, okay. So we are just doing recursion, okay. So to get all the this one, so here we are adding also, so that we get total indirect connections, and finally we are returning that particular connections, and we are doing for all the junctions. And once we do it for all junctions, we can just in maximum you can just display it, okay. So but here if you submit the solutions, you get one small error. It is only in a Python I'm talking about, okay. So the error is like recursion, there's a limit, actually limit of only 1000 recursion it can do. It can run this particular code only 1000 times, not more than that. You can verify that using this code. You can import system module, and system.get recursion limit will give you the limit for recursions. What you can do is you can increase the limit. So that's what I'm doing at the beginning. So sys.set recursion limit, and I'm increasing to 2 into 10 power 5, which is the limit for the second test case set, okay. I hope this is clear now, okay. So if you have any doubt, let me know, and yeah, if this is helpful, just consider subscribing to my channel, and like, yeah, and if you have any doubts also, you can ask me, okay, in the comment section. I will reply you, okay. Thank you, have a nice day.